Sis. First, let me introduce myself because I doubt if you all met me before. My name is Ifeoma Ndebe, and I'm a data scientist, and I'm also a mom like you guys. I hope you can hear me.
Yes, very well. Hello.
Yeah, can you hear me?
Yes, we can.
Okay. So, I want us to imagine a scenario what it was like the first time as mom seeing our babies learning how to walk. What it was really like. Um, the stages involved where the baby had to first build strength, learn how to hold her neck while sitting, or while you're carrying the baby. Then the baby started gathering strength, and then started rolling over, trying to turn around. I didn't know if anybody have experienced such or hello.
Yes.
Hello, can you hear me?
Yes, we can. Yes, I responded. Yes.
Okay, do you remember what it was like? Okay, the building how to see it, gaining balance and all that stuff. So that's what machine learning is all about. First, the time they started building strength was when you feed the machine with information. Then the next stage was baby rolling over, trying to turn around, trying to hold, grab things, and all the stuff. That's when the model explore simple patterns or rules. Then at the stage the baby started learning how to see, the baby started gaining balance. That's where the algorithm starts to balance its prediction. Though it wasn't so perfect at that moment, then the baby started learning how to crawl. That's where the machine learning begins to try out predictions and learns from mistakes. And then the baby start pulling up, standing up with support, and then next stage was walking with help and all that stuff. And finally the baby now stands alone without any help, and that's when the machine makes accurate predictions. And then the final stage the baby starts learning how to walk confidently, and that's the mastery stage. So that's what machine learning is all about. uh, Gathering data, feeding the machine with information, and then the machine learns different patterns, and from there it begins to predict and all that stuff. That's what machine learning is all about. So today, what the first thing we're going to do is talk about the introduction, what regression analysis is all about, and then why regression model is important, the examples of regression model in our day-to-day life, and how it's applicable in a real world scenario. So first, what's machine learning? Machine learning is data algorithm and an algorithm which gives us a model. Remember the I want us to imagine a situation where you want to go to the grocery store to buy some items. First, you prepare your lists. And when you walk into the store with your list, you pick up your items. And after picking up your items, you go to the counter and you're given a receipt for the items you purchased. Now, on that receipt, we have the list of items you purchased, and that receipt was for reference purposes. And that's what data is all about. Data is information, facts, and statistics we collect for reference purposes. And data could be sets of numbers. For instance, the age of students in the class, like I said, your grocery lists, your receipts, and all that stuff. But the main thing, every time we collect data, we collect it for a purpose. And after that purpose is yeah, we keep it, we store it in a particular place. That's what data is all about. So when you feed your computer with data, the next thing is the algorithm. You tell the computer steps, you give it sets of instructions on what it should do, the tasks it should carry out, and after that, the result is what we call the model, which is the output. And when we're referring to regression, we're using it for prediction purposes. That's what prediction is all about. I remember that they must have taught us the different types of machine learning, where we have supervised machine learning, unsupervised machine learning, and reinforcement learning. And under supervised learning, we have the the continuous numerical data types, which works with regression analysis and the classification. For under the regression works basically with continuous data sets. I guess it must have taught us different types of data, where we have the numerical data, which is made up of continuous data sets, which could be whole numbers, 0, 1, 2, 3 to infinity, or numbers that have decimal points. That's what we refer to as continuous data type. And then we have the categorical data type, which are data that are in group. For instance, where we have male and female, where we have the list of countries, sorry, the list of states in a particular country. And example of different types of cars. Here we have Mercedes, Volkswagen, BMW, Toyota, and the rest of them. That's what classification is all about. Category. That's where we use classification under supervised machine learning. I hope people are following with me.
Yes, please.
Oh, sorry, don't mind me that I'm watching it. I want to see how I can finish it. So, um, under supervised learning, for supervised learning, we say it's a type of machine learning where the algorithm is trained on the label data, which means that the data could be classified or categorized. And the algorithm learns from the data by finding different patterns, chains, and relationships that exist between the input and output variables, which can be used to make predictions on a new set of data. So, when I refer to labeled data, what I'm talking about is the input and output data. We could also be classified as input data will be the sorry input data just the data you feed the computer with, and then the output data is the results. So when you feed your computer with a labeled data, it produces sorry when you feed your computer with a labeled data, it produces the output, and that's how supervised machine learning works. So in regression, the output variable is a continuous value. For instance, where we want to predict the price of a house, we have to consider certain factors. We'll look at the number of rooms in the house. We'll look at the number of bedrooms in the house. We also look at the size of the size of the house in acres, or yeah, acres to be specific. So, what is regression analysis? Regression analysis is a statistical technique we use for modeling the relationship that exists between two variables or more. When I mean two variables, I'm referring to the dependent variable and the independent variable. And this independent variable could also be one or more variables. And they are all used for enabling predictions, decision making, and drive data and for data driven insights across various fields. Now, regression models, when we talk about different types of regression models, I don't want to make this class a bit complex. I'll just stick to just the two simple ones. The simple linear regression, the linear regression, which has two types, simple linear regression and multiple linear regression. For the linear regression, it's also, like I said, a statistical technique for predictive modeling. And so it models the relationship between the dependent variable, which is also termed as a target variable, and the independent variable, which are called predictors. Now, let's not mix up these things because for dependent variable, we can classify it as y, and the independent variable is also called the features when we are in machine learning. And the aim of doing this is to fit a linear equation to observe the data. And we know that linear regression is primarily used for predicting continuous numerical values, understanding the relationship that exists between these variables, and identifying the trends in the data set. Now, for types of linear regression, like I said earlier, we have two types: the simple linear regression and the multiple linear regression. When we're talking about a simple linear regression, we're referring to the relationship that exists between one dependent variable and one independent variable using the straight line. Now, the straight line is what we call the trend, and also called the model. But then, can you see my screen?
Yes, we can. Yes.
Okay, so this highlighted term, I told you initially that dependent variable is tagged as or denoted with the letter y, and then this beta zero signifies um what y is when x is zero, then beta one and and then the x, which is the independent variable, sorry, then the e is the error. So for multiple linear regression, here we have one dependent variable and then multiple independent variables. So from here, in this chart, we could see that we have graph A, B, C, and D. So for the graph A, we have a straight line where which depicts for the we know what it is when we're plotting a graph, where on the y-axis, on the y-axis we have the target variable, and on the x-axis we have the independent variable, which is also termed as features. So this line AB is the trend, is the model itself that I've been explaining, while these dots are the data, the observations. Now, if you look at it, this is a positive linear trend, and from look of it, it shows that as y increases, x increases. Now, for our chart B, this chart depicts that as y is decreasing, x is increasing. So it's a negative linear regression. Then for chart C, we discovered that there is no linear regression here. It's just not a straight line, because the major thing why it's called the linear regression is that it's a straight line. This is a curved line. Then for the chart D, shows that it's just a scatter plot. There's no direction, so there's no relationship that exists between y and x. So I've explained most of those terms. These are the terminologies when we're talking about regression analysis, where I told you that the independent variable is also termed as a predictor or the explanatory variable or input variable. It's also called feature, so that you don't get to mix it up, because the major thing is understanding these things. But with time, you get used to it. I hope you guys are following. Hello? Hello? Can you hear me?
Please, we can hear you. I was actually raising my hand to ask a question. Yes,
Oh, sorry.
it's fine. Okay, so you said when you're talking about the graphs, you said
Yeah,
y-axis indicates the target variable.
exactly. And x-axis
Okay,
indicates the feature, which is the independent variable.
okay, x-axis is the independent, yeah.
Yes.
Okay. Target variable, that's the same thing as the response, yeah? I know
Ex-
you've given
the-
different types of names.
yes. The target variable is the
Okay.
same thing as the response.
All right, thank you.
Thank you. Thank you for that. So, like I said, the independent variable is the variable used to predict or explain the independent variable. It's what causes the change in the dependent variable. Then the dependent variable, we call it the response, like you said earlier, the target or output, what you're trying to predict or what you're trying to understand. Then we have the intercept, which is also equals to beta zero. And why is denoted as beta zero is because that's the value of y when x is zero. So let me go back to the chart. So for instance, if this AB, if I extend my line A downwards to the end, maybe for instance at this spot, just that is not really showing you. Imagine if it's a real graph and the chart is from here to here is maybe 2. That means when y is 0, sorry, when x is 0, y is equal to 2. That's just what that beta denotes. Beta 0 denotes there. Then we have the coefficient, which is also the gradient of the slope, which is beta 1. And it represents the change of the independent variable on the dependent variable. It tells us how much the dependent variable changes for each unit, for each unit increase in the independent variable, assuming that all other variables are held constant. Remember, I told you that sometimes your independent variable will be more than 2, could be 2 or above. But when that's where we're talking about multilinear regression. Maybe as time goes on, you begin to understand these concepts properly. Then when we have a p-value, the p-value tells us the most important variable. Basically, we are looking at the feature variables. So these features, when we look at them, sometimes when they are more than 2, when you get your p-value, which is usually greater than, sorry, if it's less than 0.05, we say that it's significantly it's significantly important. That's significant. Yeah, it's a very important variable. That's what that particular variable means. By the time I go to the next slide, I'll really explain it to you. They will also have the term coefficient of determination, explains the result. That explains the outcome. Mentions how much of the variation in the outcome is explained by the model. So, like I said earlier, for easy understanding, the independent variable is the factor that affects the outcome, while the dependent variable is what you want to predict, the one that is being affected or influenced. It's also the independent variable is called an input variable, while the dependent variable is called an output variable. And also remember that the independent variable can be controlled and you can measure it, while the dependent variable changes in response. The independent variable is also manipulated by the researcher, while the dependent variable is observed or measured. Then on the graph, like I said earlier, the independent variable is plotted on the x-axis, while the dependent variable is on the y-axis. And like we all know, the independent variable can be one or many, unlike the dependent variable, which is always one, just the target variable, what you want to predict. And in regression, we always call the independent variable the features or x variables, and the dependent variable is called target or y variable. Like we all know, as data scientists, we use the independent variable. It helps us to build the model, while the dependent variable evaluates the model. Now, everyday application of regressions for moms. Why I narrowed it down is because we are all moms. I just
Yeah.
try to make it simple, simpler. Sherry, do you want to ask any question?
Yes, please.
Yeah, okay.
Can we go back to the previous slide?
Okay. This one, this or this one. Which one? Hello?
Oh, sorry. The features of both dependent and independent variable, the one you just kicked.
Okay, okay, okay,
But yes, this one.
okay.
So first you said that dependent variable can be one.
Yes,
Yes,
your dependent variable will just be
I understand. Yes.
one. Yeah,
Now, when you say quantity here,
yeah, quantity. Yeah, as I said, just
either can
one.
be
I
one
mean,
or many.
yes, not only for independent variable, we could have two features. We could have three or more. That's where
Okay.
it's applicable in multiple linear regression.
Okay. So let me just set an example for better understanding. Like I'm trying to get something. So for example, say I'm working on something and I have four independent variables. Say temperature, moisture content,
Yeah.
pressure. Let me just use those, right?
Yes.
And then I have the independent variable to be maybe juice quality um, or yield, as the case may be. So when you say can be one or more, or you said it's always one. There was a statement you made. I was just
Okay.
trying to understand.
Okay. When you're talking about actually now, what you're trying to predict is the yield, isn't it?
Yes.
The yield is now the target variable, which is just
Which is
one.
one. Okay, so for example,
Yeah.
if we're talking of the effect of temperature on that yield, so temperature can be maybe at 60 degrees,
Independent variable.
at 50 degrees, 60 degrees, 70 degrees, 80,
Yes.
several.
Yes.
But all of
Yes.
that effect only on the yield. Is that what you mean?
Only on the yield. Exactly.
All right,
Exactly. You're
perfect.
correct.
Thank you.
Thank you. Yeah. Welcome. So examples. Like I said earlier, the regression model is to help predict numbers, and numbers could be the weight of your baby. For instance, you want to predict your baby's weight gain, and we could use a independent variable could be the age of the baby, or the milk intake, or the sleep hours, number of sleep hours for the baby. So that's where we'll tag that as multiple linear regression. For linear regression, like I said, we have one feature and one outcome. Multiple linear regression, many features, one outcome. So let's don't mix it up together. Let's just try and understand it the way it is like this. And for instance, the mom wants to predict her monthly budgets. So you have to put into consideration your income, your family size, and location matters too. Yes, for instance, for those that are living in the north, if you want to price tomatoes, for instance, at the moment, now tomatoes could be a painter could be like 4,000 or more or less. While those that are in the southeast could buy a painter of tomatoes for 6 to 7,000. So you can see that that location really matters a lot when somebody is trying to predict monthly budgets or cost of living. So yeah, your monthly when you're tracking your monthly projects and the rest of them. That's what prediction is all about, basically. That's what you're trying to predict. So your monthly budget is what you're trying to predict. You have to now consider certain factors that are very important. Like I said, the income, the family size, and location. Then, for instance, you want to manage the time for your chores, and you're trying to predict how many hours will I use to do certain things. Maybe on a Saturday you want to ensure that you finish within a specific number of hours. You put into consideration the number of people that are helping you to work, your number of children, if you have helping hands too. You put into consideration all those things. So the number of children, people that are helping you to work, if they are available, those are your independent variable. Then the time, now that you're trying to predict is your target variable. I hope you're getting along with me.
Yes.
Okay. Like I said earlier, for simple linear regression, where we have just a single input and a single output, baby's age and baby's weight. Baby's weight is what you're trying to predict. Then study hours, you want to predict the exam score of a child who is in primary school. You have to put into consideration the number of hours the person studies. Then for us to expand this into multiple regression, we can also add the screen time. The screen time and study hours now becomes an independent variable if we are looking at it as a multiple regression. Then, for instance, you want to predict the tip amount of a waiter in a restaurant. You could use total bill. Another thing, if you want to now extend it into multiple regression, you could use the size of the table, the day the customer comes in. All these things affect how much you be tipped. The total bill too. All these things are very important features. Okay, I've already explained this part. So other terms when we are looking at regression model, we have a p-value. In simple things, p-value is a truth detector. A low p-value, which is typically 0.05, anything less than 0.05 means that the variable is very important. Then a high p-value, anything that is greater than 0.05, then that variable is not, it doesn't matter at all. We don't need it. It's not an important feature. Because I told you that p-value is only used to identify the important features when you are looking at multiple linear regression. So for instance, looking at the restaurant example where you want to predict the tip amount of a waiter, for a waiter, sorry. We put into consideration the total bills for the month, the days of the week the customers coming. Then the customers, is it the male customers that tip more or the female customers? Now, if our regression model gives us those figures, where we have a variable, total bill, day of the week, and gender. Remember what we're trying to predict is the tip, which is the target variable. And we are given a coefficient of 0.125 minus 0.05 and 0.02 and a p-value of 0.001, 0.065 and 0.03. Now
A
looking
question.
at the, say,
Okay.
yeah, what we're trying to look for is the
Finish.
p-value. Yeah, what we're trying to look for is the p-value, sorry. So
Finish this. I'll ask a question. Sorry.
okay, so looking at this now, we could say that this value, the total bill, and the gender are very important features, while the day is not really important. But it doesn't mean that we have to drop them. It's by the time we play the way when we get to the R squared, when we are evaluating our model, then we now know whether it should be dropped or not. So you wanted to ask a question.
Yes, I'm just looking at this table. I remember you mentioned coefficients was like the gradient or the slope, which is
Exactly.
yes, which represent the change in the independent value
Yes.
variable. Yeah. Here, for
Yeah.
example, total bill is a um variable, right?
Yes, an
So
independent variable.
yes, so can you use this table, the coefficient here, to explain? Can you explain the coefficient using this table? So is this like maybe for different days, um,
Yes,
the
this could
change
be different.
in the total bill between days or something?
Yes, this is a different date. This should be a different date. Days will not be uniform across, but we just for one
Definitely.
particular day. You understand? You just be
Yeah.
for one particular day. Then this coefficient means that for every increase in x, the coefficient y increases by 0.1. y
Mhm.
increases by 0.12.
Okay.
By the time we enter the real modeling, you really understand it. Okay.
Thank you.
Okay. So, like I said, a low p value is an important predictor. You keep it. A high p value may not have much effect, and you may drop it. Like I said, if the p value is less than 0.05, we say that that feature is statistically significant and has a real influence on our model. So we're back to that same coefficient of regression. That coefficient you were asking me that time. So this example here is to predict exam score, which you already know that whatever we are predicting is always our y, and based on the study hours, number of study hours x, which is our independent variable. So this is a simple linear regression equation. Now, why you're not seeing it as an equation is just because I just put the terms. If I present it as y equal to 40 plus 5x, that's the real equation now. You understand?
Yes.
Hello? You understand? So that's the real equation now. So remember that the 40 is the intercept, which is what y is when x is 0. Okay? And then the 5x, x here signifies the study hours. The 5 is a coefficient, which is the gradient of the slope. So it means that for every hour, our score increases by 5 marks. Is that making sense?
Yes.
Hope I'm carrying everybody along.
I was going to ask.
Okay. Yeah, I'm listening.
No, I was going to ask the same question, like how, like
Okay, we're going to
everybody's.
ask the same question. Okay. Okay. So now the next thing is R squared. R squared helps us to know how well the model fits the data. And our squared usually ranges between 0 and 1 when it's calculated. And if we have a 0, if it is R squared gives us 0, it means that the model explains nothing. But if it gives us 1, it means that the model explains everything. So let me go to the next slide to explain it properly. We have R squared. Yes, why is it also called coefficient of determination? What does it determine? It tells us, like I said earlier, how much of the variation in your outcome, which is a dependent variable, can be explained by your model. Simple explanation. Now, like I said earlier, the grocery cost, where you want to predict it, when I talked about family size, income, and location. Now, our X1 is a family size, our income is X2, and location is X3. So these are three independent variables. Remember that grocery cost is the dependent variable. If our R square gives us 0.82, it means that 82% of the variation in the grocery costs is explained by your model. 82% of the changes in your grocery costs is being explained by the model. That's just what it means. While the remaining 18%, 100% now, 100 minus 82, we have 18, could be influenced by other things like the discounts, weather, brand different preferences, and the rest. Hello.
Yes.
Okay. So when we want to really view how our R squared is, like I said, R squared is also known as coefficient of determination and is a proportion of the variation of y explained by the independent variable. It also measures the goodness of fit. So for this one here, comparing the R squared for different linear models, same data. Now, R square gives us 100%. That means that is a perfect model. You can see how well the observed variables fitted in into that predicted line. I hope you guys are seeing my screen.
Yes, please.
Okay, so it said great for those. Then for the next one on the right side, it says good, where R squared is 80%. You can see that when we're trying to connect the dots, not all the dots fitted in, and that's why that R squared is 80%. Then when it's a bit scattered, it said it's just moderate. 40%, R squared is equal to 40%, which is moderate. Then inconsistent, not all the dots, which are observed variables, fell into the predicted line. So that's just what R squared is telling us, that 80% of a change, variation is change. And variation also is also when we're talking about the change in the output being explained by the input variable. So other evaluation metrics for regression task, we have the mean squared error, which a low mean squared error equal to a better prediction. We have the root mean squared error, the mean absolute error, and the mean absolute percentage error. All this should be discussed in the next class. But there are certain assumptions that must be obeyed before we use a linear regression. Remember, when we're talking about linear regression, we're always talking about that line, this line must always, there must be a linear relationship between x and y. If there is no linear relationship, sorry, we can't use it. Then number two is homoscedasticity, where we have equal variance. When we're talking about equal variance, we're talking about how far our data set is from the mean. Remember, the mean is also referred to as average. So when we're talking about variance, we're talking about the spread of this data from the average. So that there must be an equal spread. That's what it just basically means. The spread must be equal. If it's not, we can't use it. Then multivariate normality means that there must be a normal, the data set must have a normal distribution. Then independence means that the observations should not correlate. When we talk about correlation, we are referring to the degree or the strength of relationship that exists between x and y. Then if it lacks multicollinearity, what I mean here is the predictors, which is the independent variable, sorry, should not be correlated. It should not be correlated. And then outliers is not really necessary, but I hope you guys know what outliers is. I didn't need to explain it to you in your previous class.
You could just explain it if you don't
Okay.
mind.
So let me explain it to you. For instance, if we have a student in the class, maybe university students, and we have students that range between 16 to 24 years old, then all of a sudden we start seeing somebody that is 55, 60, 70. You can see the normal age of those students range between 16 to 24. But all of a sudden, we are now seeing somebody that is 55, somebody that is 66, somebody that is 70. So that's 60, that 55, 60, and 70 are called outliers. They are extreme data, they are extreme values that do not fall within the normal data sets. Like this picture here now shows that this data here does not fall within this space, so it's extreme. I hope you understand this one that this one I'm showing down here under the number 6 outlier.
Yeah.
Are you seeing it?
Yeah. Yes, we can see. I can see that.
Also, we also need a regression assumes that okay, I've explained this autocorrelation thing. Then overfitting, we have something called overfitting and underfitting. And overfitting means when you train your model with so much information that it begins to perform perform so excellently. That means you fed your model with so much data, which leads to overfitting. It's too well trained. That's what it means. And the only way we can avoid overfitting is using regularization techniques. And we have underfitting when you don't feed it with enough information and the model fails to perform effectively. So then, well, okay, for this, when we have regularization techniques, for what we use to solve them is lasso regression and ridge regression. I don't want to go deep into this because this is advanced regression. I just understand the simple things.
How is regularization done? Apart from this,
Okay. Okay, yeah. Regularization is used when you're overfitting your model. When you feed
Hello, Chumaya.
when you feed your
Hello, Chumaya.
hello
Hello,
yes.
Chumaya.
when you feed your model with so much you feed your model with so much data.
So I'm basically asking, how do you regularize? But if you think
Hello?
that is more than the scope of this class, we can leave it.
Say?
One
I
superhero.
was asking, so how do you regularize? But I'm saying if you think it's
Okay.
more than the scope of this class, we can leave it.
Yes, it's a technique. It's involved in modeling data, which I'll show you in our
Yes.
when we enter the.
Okay. Please, I can't hear her. Am I the only one?
No, same here.
I want to believe she's attending to that child. Maybe. I don't know.
Was it coming from her side?
I think it's from her end if all of us can hear ourselves and not hearing her. I hope she's not talking. No. She's the one that posted the meeting link, right? I'm thinking if we call
Yes,
her
she
on
has
WhatsApp.
already gone out. She's no
Sorry?
longer here. I think the network has taken her out.
Oh, really?
Mm.
Faith, is it just you and I that is here?
Yes, so it's just you and I. Mrs. Ibuku just left too.
Wahala. Which one is, are you the one recording? Which one is this Faith's Phantom?
Is it not this my recorder? Just they
Not
enter
there.
anywhere when they don't send down.
Yeah, good for you if it's recording now. I'm taking notes.
Yes, it
That's
is.
nice. It's an AI tool. I'm seeing
Yes, it
Fathom
is.
3.
Fathom, yeah.
Wow. So when you're in meetings, it records and
Yes,
takes.
I use it for work.
Oh,
Yeah.
nice. So it gives you
I'll
text
show
as
you.
well.
Exactly. Text and record.
Oh, wow.
Sharing for the.
It's fine. Welcome back.
Welcome back, ma. Mm.
Thank you. Hello.
Yes, huh?
I can hear you.
Can you see my screen?
No, not yet. Power?
Yeah, it's up.
Wahala.
It's no longer showing no.
So can you see my screen?
No, it's not showing.
Can you see my screen? Hello.
Yes, now, yes.
Okay. So I'll explain what variables are dependent and independent variables. Okay, so let's just start with the data set we're going to work with is tips. We're using tips to work with. So I'll just explain the codes. I guess we're all familiar with the basics, the data processing and the rest of them, pre-processing and the rest of them. How to load our data using hello
Yeah, I think we treated it last week.
last week. Okay. So I denoted my data as DF, and then if you want to for instance, we have SNS is the Seaborn library, which has data sets loaded in them. There are some data sets already in there. So once you
Sorry, ma'am, you did SSN instead of SNS.
sorry, Jerry, don't mind me. Once you run this, sorry, not even run my code. So after importing our libraries, so there are some data sets that are already existent in this SNS. Sorry, I need to get some. We have. I don't know if we worked. If anybody has done on Titanic data set before. This is where you can also load it from. Sorry. Let me just concentrate on the one that I have here now. Not. So this one is tips. Tips is the title of the data set that we're working on. So to run it, I to get the first five rows, I grant df dot head with double brackets, and it showed the top five data sets, the first five. You know that for Python codes, whenever the index starts with 0, and then we have the total bill, the T, the sex, which is either male or female, the smokers, which is either you smoke or you don't, the day, the days of the week that the customer visited the restaurant, then the time, and then the size of the table, which is the number of persons on the table. DF is the last five rows in the data set. So DF info gives us a brief description of what the data type is all about. For total bill, you can see that is a float. Float means it's a decimal point. Then the tip, which is what we are trying to predict, is also in decimal point. The sex is a categorical data, which is either male or female. The smoker is either yes or no. The days of the week, which is Monday, Tuesday, Wednesday down to Saturday, Sunday. Then the time of the day, is it morning, afternoon, or evening. Then the size, number of persons on the table. Now, this D type here shows that is a summary of the data type. For categorical data, we have 4 types. For float, we have 2 types, and for integers are strictly whole numbers. We have just only one integer, which is the size of the table. DF shape is a row. The first number in the bracket is 244, which shows that we have 244 rows and 7 columns based on 1, 2, 3, 4, 5, 6, 7 columns. Yes. So DF column is to bring out all the columns, all the list of columns, and basically looking at this, we can see that we have over 6 independent variables and just one dependent variable, which is what we're trying to predict the tips. We check for missing values, which we have no missing values. We check for unique values. The total bill is 299. The tip is 123. Sex, like I said, just male, female. Smoker, yes or no. Day, they use only 4 days of the week. And then the time, 2, which is lunch and dinner. I think that's what they have there on the data set. Then we check for missing values, and we can see that there are no missing values. Then we check for duplicate, and we discover that there's only one duplicate. We have to drop that duplicate, which is not necessary for me. Then the statistical analysis. This DF describe is strictly for only, it's just to describe only the numerical values, and that's what I need. Where the count is the number of observations, the mean is the average, standard deviation is the square root of the variance. The mean is the minimum number, and then 25%, that's the quarter, the first quarter, second quarter, and this 50% signify mode, and 75% of the data set, and then max is the highest range of in the data set. Merely looking at this, we don't have any outlier here. They are all within a specific range. So let's go straight to exploratory data analysis. First is these plots. Here I have total bills, which shows that it's a normal distribution but slightly skewed to the right. And if the data is slightly skewed to the right, it means that most of the data is on the left side. Then bivariate analysis, when you compare two variables, where we have the total bill. Okay, so I said when we have the data is skewed to the right. I don't know the total skewness. We have the right skewed and the left skewed. I don't know if they've explained that aspect to you when you're trying to describe your data set. How it is.
There's an idea, but no, not in this class.
Okay, okay, okay. So basically looking at this, we can see that the data is mainly concentrated on the left side because it is right skewed. It means that the mean is greater than the median and greater than the mode. Unlike this one that is concentrated on the right, on the left side. It has a long tail on the left side and the data is concentrated on the right side. On the right side. And this is the scatter plot. This is a scatter plot. You can see the normal distribution, which is, like I said, it is skewed to the right side. And this is the trend. This is the linear, which shows that there's a linear relationship that exists. So multivariate analysis, where we have pair plots, plus relationships available in the data. All the relationships are available in the data. I've explained this. This one shows that there is a linear regression. This one too.
What do you mean?
Say?
Sorry.
Okay. Then one would want to visualize the categorical data sets. The first one I used was cat plot to show us the male and the female based on the total bill. And from here, we can see that the males are the people that tipped more. Then from this chart here, we could see that on Sunday, they spent more money on Sunday. So it's very possible that they have more customers that visit their restaurants on Sundays. Then this is the count of customers by sex. Here, like I said earlier, the males are more than the females. Then the number of customers that visit per day. You can see that even though that they spent more money on Sunday, it's not that they had more customers on Sunday, just that they have customers that spent more money on Sunday. But the days with the highest customers is on Saturday. And the days with the least customer is on Friday. Now, count of customers by day and sex. Now, mainly looking at this, the blue depicts male customers and the yellow depicts female customers. You can see that even on Thursday, the female customers were the highest. Then on Saturday, we had more male customers compared to the female customers. And same thing was replicated to on Sunday. Box plots, remember I told you about outliers. This one is showing that there are outliers here based on the customers that tipped more. So the male customers tipped more money. These dots represent outliers. That the customers, the male customers, most of them tipped $10, most of them tipped $9, most of them tipped seven and more and less, sorry, compared to the female customers. This is the same chart, just different colors. So now this is the regression plots. You can see that both the male and the female are both have a linear regression, which is the same thing here. I think that's all about the visualization, multiple, yeah, the visualization, yes. So let's enter machine learning proper. So the first
A
one,
question. Sorry. Question,
yes,
please. Okay. Sorry, I might make you scroll all the way back to the top. Sorry.
okay, okay,
I didn't want to interrupt.
okay,
Yes. So, in our previous class, I think
yeah,
we had done this import panda thing
yes,
to clean up, to do data cleaning. So
yes,
import pandas as PD, import
yes,
numpy as NP and all that. I think the
yes,
only thing, okay, even the Cbond, we had done that.
yeah,
But when, just like you imported this list, this document, tagged list, right?
yes.
I was trying to import my own document, but it was showing me that panda, one of the pandas, whatever, is not defined or something like that. So I could not proceed.
Okay.
So
Have you been able to resolve the issue?
no, I haven't really taken time to sit down and look at it. So I could even ask questions in the group.
Okay,
So I
maybe
don't.
you share it
Sorry.
with me so I can look at it. Maybe you screenshot and send it to me.
Okay, I'll look for. I'll do that. So I'm using my
Alright.
phone now, and that's on the system. Then the file you imported, the list. It's something you
Yeah,
uploaded before, or is it? Was it? Did it come? It was it inbuilt like part of the libraries and all
yeah,
that.
it's this is an inbuilt data set.
All right,
It's
that's
under
fine.
Seaborn.
Okay.
Under Seaborn. I did not this one is just not this one is not from Excel, it's just from Seaborn Gomo.
Okay, no problem.
It's an inbuilt data set.
Yeah. I'll ask you because if I want to try to do what you did now, say I want to practice, I have a
Yeah.
feeling that I am going to get the same issue
No, you
if
won't.
the
You've
said
used
panda.
Seaborn before.
Sorry,
You've used Seaborn before. Is that the first time you are using it?
everything here is first time.
Oh, if it's the first time, you have to do pip install.
we we did a lot of that. The ones that were not, yes, we did. I actually did all of that. But when I now started using pip install, Cbond, all of them, except I'll go and look at what I pip installed and see if that particular panda did not install well.
Okay.
Well, I'll check and then I'll screenshot for you if I.
All right, no problem. Thank
Thank you
you.
so much.
You're
Yes.
welcome. So let's go to the regression model proper. So the first one is simple linear regression, where I had to identify my the most important this thing was variable here is the total bill and then the amount of tip. You know what we're predicting is a tip which is automatically denoted as y, and then the independent feature, say the feature independent variable total bill denoted at x. So when you want to do your model, just label it with regression, linear regression in bracket, model.fit xy, then print your intercepts, which is your value of y when x is 0, 0.92, and then your coefficient 0.12. Then for multiple linear regression, first there's a lot of process involved in this one because we had categorical data sets, and I had to convert them to numerical data sets. But machine learning does not understand numeric categorical data sets. You have to convert them to a numerical data for you to be able
Number two.
to understand it. Sherry, are you asking me any question?
No, please.
Okay. So first, convert the categorical data to numerical data, and there are different processes. The first step is one hot encoder. This is when you have more than two or more categorical features which do not have to follow any particular order. They are called unordered categories and has many binary columns such as example what I used here was fruits. And for instance, we have apple, banana, and orange. So the apple will be denoted as 1, while the orange and bananas will be 0, 0. Then when it is now banana, it will now be 0, 1, 0. And when it is orange, it's now 0, 0, 1. That's how the code will be when you use one hot encoder. Then when you are using label encoder, it said it's suitable for two or more data types. For instance, when we have male and female, you you denote male as 1 and then female as 0, or use yes as 1 and no as 0, or booleans where you have true or false. True will be 1 and then false will be 0. But sometimes when you use those things, the 0 comes out as none when you're running your code. So I had to change them to, instead of using 0, I had to use -1 for me to easily understand. So I denoted my female as -1 and male as 1. Then for the smokers, I denoted no as -1 and yes as 1. Then for the time that the customer visited the restaurant, I used lunch as -1 and dinner as 1 for me to be able to run my process the convert it to numerical data sets. Then for the number of days, the days are a different. We have 4 days or so. So I used label encoder. So I first, after running the codes, I had to view the first 3 data sets, and this is what I got. Remember that -1 for sex denotes female, -1 for smoker denotes no, and then day 2, it could be Monday, Tuesday, Wednesday, depending on how it's run. Then the time of the day for 1 denotes dinner, and then -1 denotes lunch. Then size was just numerical data, so I didn't touch that. So first I had to identify the independent variable and the target variable, where by features denoted as X, where total bill, sex, smoker, day, time, and size. And then my Y, which is the tip. So I splitted my data into training set and test sets. Remember, the training set is the one the one you're trying to used to run your model, and then I divided by 80/20. That's why the test size here was 0.2, where 80% is training data set and test set is 20%. That's to evaluate how well the model is. So I fitted my model and I was able to predict this. So it means that most of the tips will be $2.9, 1.9, and the rest. I think the highest tip here is about $6 or so. $6.6. So now the model evaluation and metrics to see how well my model is. The first one is the least square best fit line equation. This least square is the same thing as the linear regression equation,
Hold
where
on.
Sorry.
Sorry.
Yes, yes.
If I understand, like now that we did what you just did, just scroll up down a little up
Scroll down
here.
or up,
Yeah.
up,
No,
up.
here, here.
Yes.
So if I understand, this array shows us the distribution of the tips, like
Yes.
how much different persons
With
gave,
it. Yes, yes, yes.
which we did not know. So we
Yes.
are
We're
predicting.
predicting it exactly. You're correct.
Okay,
Yes.
okay.
You're welcome. Thank you.
Thanks.
So remember I told you the coefficient, which is the gradient. So the coefficient here is 0.9, 0.09, sorry. Then the total bill, which is the independent variable, and the model intercept, which is sorry. Yes, the model intercept, which is the constant, sorry, 0.5, what the value of y is when x is equal to 0. So this is the equation.
Is this defined somewhere already?
Yes, it was in the this thing slide.
Mm, okay.
In the slide. Remember, let me show you.
On that
What is
table,
the
is it on the
equation?
table?
This one. Are you seeing this one I highlighted? What y is equal to? Y equal to 40 plus 5x. Are you seeing this? Are you seeing my screen?
Yeah, but I can't see the one that you had highlighted.
Oh, okay, sorry. Let me increase it a bit so you can see. Let me increase the font. Yes, this y equal to 40 plus 5x. Do you remember it? Now I tag this as an equation.
Um, I wasn't here when you started.
Oh, sorry.
Yeah.
Sorry. So let me just
Y
repeat
equal
this
to
thing.
40 plus 5x. Is that the one you're
Yeah,
talking about?
yes. That's an equation. That's the linear equation.
Yes,
Remember that. Sorry.
so I'm asking from that equation, at what point, what did we do to now have this
Okay,
0.57 defined here?
okay. That's the mathematical aspect of it.
So is there no, all the things we have been doing, is there no place where this was done that it is showing? That's what did we miss that?
No, see it here. Look at it here. See it here.
Exactly, this is what I was asking. Okay,
Yes,
okay.
right.
So from this, what you coded here under simple linear regression, what you
Yeah,
coded here gave you.
I just put it in the equation. I just printed out the equation properly for you to see.
Okay, so it gave you intercept and
Yeah.
coefficient. Okay, all right, that's fine.
So this is the training accuracy. This is the test accuracy to test how well your model is. And then this is the root mean square error. They're going to explain these words to you people in your next class. And then this is the mean absolute error. And then this is the R squared. From this R squared here, that is 0.044. It means that it's just a moderate, how do I put it?
Moderate
Moderate
fit.
model. Just a
Okay.
moderate model. That's where I'll put it. So if you want to investigate further, I didn't know. I was solving it, but I didn't really have enough time. But so let me just go straight to the multilinear regression equation. So this code here is printing out the multilinear regression equation.
Sorry, before you continue.
Okay.
So you said it's a moderate model, kind of.
Yes.
But
Yes.
we want to look at, is it a good model now? Like that
Yes.
is the outcome we're looking for.
Yes. So
So it means that we have to do something.
work, yeah, we're going to work more for them. You have to work seriously, as in there's a lot of work to do on it.
So what do we do to correct that, to get it going?
Thank you. We'll get into it.
All right.
So this is multiple linear regression equation. Remember that our model coefficient for total bill was 0.09. Then that of sex is 0.02. Then the next one is the smoker. So let me show you where I had to bring out those features and their names. And these are all of them. These are all of them. This one's here. These are the features. And these are the coefficients. These are the coefficients too. So for feature number 5 is size. Feature 0 is 1. Sorry, feature 0 is total bill. Then feature 1 is sex. Feature 3 is day. Feature 4 is time. And then feature 2 is smoker. Mainly looking at this. Mainly looking at this. If you want to identify the most important features here, remember that when we say that it is greater than 0. It is greater than, it is not an important feature. So for this size is not an important feature. Sorry, size is not an size of persons on the table is not an important feature. This total bill is 0.09. This thing says 0.05. You can see that most of the p-values, the only important feature here is sex. You look at the p-value, and that is why this model, these tips for regression analysis is a bit complex. Because when I was working on it, I was trying to do, if you look at it, when I was trying to further investigate to know why, I've not even finished it. Maybe tomorrow I'll come up with a solution to it. So this other part was when I wanted to predict the values. When I wanted to predict the values. So for instance, if my total bill spent in the restaurant is $20, the sex denotes male. The smoker, there's a smoker on the table, which is one yes, which is one. Smoker is yes. Then the day is day 2. Then the time, which is 1. 1 denotes dinner. And then size of persons on the table is 4. So this is an example of a feature. So I created feature 1 and feature 2 with 2 different scenarios, and then my column names, and then I predicted. So for feature 1, to predict it, I got $3.28. So anybody that tips $20 with 4 persons on the table could tip $3, $3.28 to the waiter. Same thing is applicable for feature number 2. Feature number 2, where if the total bill spent was $24.50, then they could the people on that table could tip $3.82. I hope you guys are following along.
Yes, but it looks like it's just you and I that is here. I
See,
don't know if
so I think I'm done for today.
okay.
I think I'm done for today. This further investigation, I want to go and work on it properly.
Okay. Thank you so much.
Yeah, so but when you're looking at it, when I did my correlation, because correlation is to determine the relationship that exists, I only discovered that there was just no relationship between all of them. The only thing that had a strong relationship was the tip,
Mm,
and correlation is very important. There must be a strong correlation that exists.
mm.
So,
Okay.
all right, so
Thank you.
thank you. I hope
So,
Thank
that
so.
you.
you were saying,
Yes, thank
for a
you.
moment, Faith, I felt I was the only one here.
Oh, there's another person here.
How many of us are here?
There are 3.
Oh, okay, okay, okay.
Please, I would
So,
like to get the recording of today's class. Thank you.
okay, okay.
Yeah.
So
Yeah.
now that
Thank
you
you.
know, I'll suggest that you should practice now that you understand the power of regression, because this is an opportunity for you to apply this in the real world scenario, especially your
You know,
day-to-day task.
apart from this, I've been asking you so many questions.
No problem.
So
No
actually, my
problem.
project has a lot of data analysis and all of these regression things. Even when studying, like this
Okay.
class has really helped me to understand most of the things I've been studying. So I guess that's part of the reason I could relate and ask a lot of
Okay.
questions.
Okay.
Okay. Thank you so much. I know
You're
that the
welcome.
the, the data analyzing part is, I mean, the data, all this coding part is still something, but
Yeah,
well,
it's not that easy learning it. You have to keep practicing and practicing until you become perfect. That's just the main truth. You don't learn it
mm,
in one day. Most of us, it will tell you the number of hours we put in just to make sure that we are up to date with the trend. You know how it is in the industry. So we just have to continue to practice so that they don't leave you behind. That's just the truth.
mm. It's all good. Thank you.
You're welcome.
All
You're
right.
welcome.
So tomorrow, 7 o'clock, I guess.
Yes, but I don't know if I'll be the one taking the next class yet. I don't know yet.
I thought we are not done. Okay.
We're not even done with last week's OZ. We're
Seriously,
supposed to
because
Last week's
when I
own.
heard her voice, I
ah,
was like, this is somebody else. So, and then they're
ah,
not also informing us that, okay, you're going to be having another coach or lecturer or
Oh,
something.
yeah.
okay.
Please,
So, what happened last week that you are not yet done with it?
no, we don't know, really. And just
In
like
fact, I
we're
think it even
ending
started
with
from
you.
last 2 weeks. We did not complete visualization. We didn't do it actually.
Okay, the
And then
exploratory data analysis aspects.
yeah, the
That's
version
Like,
before the
like now you're
visualization.
you're talking of something else, some other things we need to do. So it gives me the impression that we are not done. But now maybe next week or tomorrow someone else comes.
Uh-huh. That's it.
So
okay. So maybe I'll ask
you are a part of the team, right? Or you're
no,
just facilitating.
I'm just facilitating. I'm not part of the team.
Okay, so so the other persons are the right persons to talk to, not you. Because I wanted to say that they should give us an idea of how we're proceeding. We're going to have a test. Give us from now, like maybe a timetable. Or Faith, is there something like that that I'm not aware of?
No, not at all.
I
Nothing
don't
like
think so.
that.
uh
No, nothing
So
like
if
that.
there will be a test, when is the test going to come? So that I don't just say next Saturday writing test or something.
No, I don't think there's anything like tests. Did they say there's going to be a test? I think it's usually
Something.
projects. Usually
Oh,
projects
project.
they give, yes.
Okay. Okay. A
And
time frame
yes.
is given, I
Yeah,
guess.
the time frame is given, which you
And
can
is
go
it
and look at
usually a
your
group work?
previous codes because they don't
Okay.
expect you to know everything.
Is it a group work usually?
Sometimes it's usually group work.
Oh, okay. Please, we have the prefer. My problem also is, I don't know if it's because I'm using my phone. Like if you share this recording, it's very difficult for me to see the fonts. It looks very small on my phone. I don't know if it's because it's a phone. Faith, please, are you experiencing the same thing or you use your laptop? Hello?
Oh, sorry, I thought I was muted. I used my laptop and it's not appearing small. I think
Oh,
it's
okay.
because you're
Try
using
and
phone.
use
Probably.
laptop.
All right, I'll do
But when
that.
you want to run codes too, you still have to use your laptop.
Yeah. What do you want? Okay, thank you so much. Good night. Thank you.
Okay.
Thank you. Thank
You're
you.
welcome. Thank you.
Good night,
Good night,
everyone.
everyone.
Um,
Bye.
Thank you. Good night.
Good night, dear.